Hello everyone. We're going to start today's lesson off just by reviewing two problems here where I want you to solve. Now what you were doing yesterday for the graded assignment, you weren't solving quadratic equations, you were just rewriting them in vertex form to graph. So now we go back to what we were looking at the very beginning, which is we want to solve the quadratic equations. Remember, when we solve, we're finding the x-intercepts or the zeros of the function. So pause the video, give both of these problems a try, and then resume playing to see if what you did was correct. Notice it does say solve using any method. All right, so if you need more time, just pause the video again. What we always want to try to use first is to solve by factoring. So what I'm going to do is just bring this 3 to the other side by adding it. And then let's see if this factors. So all we can do is give it a try. So the only way to factor 2x squared is 2x and x. And then for a 3, I'll have a 3 and the 1. What's nice is because this 3 is positive, that means my signs have to be the same, and then they both need to be minus. So let's check to see if this works. On the outside, I'm going to get a negative 6x and a minus 1x. That is not going to give me a minus 4x. So let's see if I could switch these around. Nothing else can change, so let's try the 3 here and the 1 here. Now I'm going to get a minus 2x and a minus 3x, not giving me a minus 4x. So guess what? Factoring is not going to work here. If we want to try completing the square, we can, but we'd have to divide everything by 2. So in this case, I want to just use the quadratic formula. It's going to be so much easier. So again, it's x is equal to the opposite of b plus or minus square root of b squared minus 4ac all over 2a. I would have gone with completing the square, usually if my leading coefficient is going to be a 1. That's when it's always the easiest. So b is negative 4, a is 2, and c is the positive 3. I have to move everything over to one side, so c is positive 3. So I'm going to get x is equal to the opposite of b gives us a positive 4, plus or minus square root. Now b squared becomes a positive 16, minus 4, and then a times c will give us a 6. All over 2 times a, 2 times 2 will give us 4. Now I'll take care of what's underneath the square root. That's 16 minus 24, so I get a negative 8. And that's a great indication that that's not going to factor because we're going to have an I in our answer, plus we have a radical still left. So I need to simplify the radical 8. That's going to factor into 4 times 2. I'm going to take the negative out as an I, but then radical 8 simplifies to a 2 radical 2, so I'm going to have a 2i radical 2 all over 4. And now we could still simplify the 4s with this outside 2. I could divide all 3 of those by 2, so we're going to get 2 plus or minus I radical 2, or really 1i radical 2, all over 2. So there's our solution. All right, for number 2, let's bring everything over to the left side here. So we'll have 3x squared plus 10x. We have to put this in the right order. And then minus 8 equals 0. Let's try to factor again. The only way to factor 3x squared is 3x and x. And then let's try maybe 4 and 2 first. Now my signs have to be different, and I need to end up with a positive 10. So this is going to give me a 6x on the outside and a 4x on the inside. And that will get me to a 10x if my signs were the same, but they're not. They have to be different. So that means I need to subtract to get a 10x. So let's try switching those around. Let's try the 2, then the 4. Now on the outside we'll have a 12x and then a 2x. And 12 minus 2 is a positive 10. So we'll put the plus here and the minus here. So now I just said each factor equal to 0. Add 2 to both sides here, so 3x is going to equal a 2. Divide by 3, so x is going to equal 2/3. Over here, x will equal negative 4. So our solution here, negative 4 and 2/3. And you could have absolutely used the quadratic formula here. I'd stay away, again, from completing the square. You'd have to divide everything by 3, and then you're definitely working with fractions. All right, so every type of polynomial we've been looking at so far has dealt with quadratics. So we're going to move on to other powers of polynomials here. So not just quadratics, but larger degrees. So our goal for today is to be able to find the zeros, which means the x-intercepts. We could also be asked to find the y-intercept. And then relative extrema. So this was like that number 18 last week I had you guys working on. Please make sure you have a graphing calculator or Desmos to use with these problems. All right, so when I refer to the degree of a polynomial, that is the largest power of the monomial terms. Monomial just means we have just single individual terms, all of just one variable. So what can the degree tell us? The degree can tell us the max number of complex solutions or complex zeros that a function has. If you recall, it's all in how we're, like the context, but all in how we're using it. The zeros are the same thing as the x-intercepts. They're the same thing as the roots of a function, which is the same thing as the solution to the equation. Now the number of complex zeros, remember a complex number is a plus bi, real plus imaginary. Same thing is true of complex zeros. It's the number of real zeros plus the number of imaginary zeros. So we're just going to draw a little graph of a general curve here, and to kind of indicate as much on this graph as we can. So go ahead and draw something that looks like this. I'm going to first put the points indicating these would be the x-intercepts, or out of what we're taking a look up here, these would be the real zeros. Here, here, and over here. Right up here, what I have in red, that would be a y-intercept. Right here in purple, that would be a relative max. That would be like our peak, and then our valley would be over here. This is what we would call a relative min. Together, we call them the relative extrema. Now, when we go to state the zeros, we're just going to make a list in set brackets, and we only want the x values. We write them as a comma-separated list. When we go to write out what extrema are, this is how we always want to phrase it, because the extrema are the y values. So we're going to use this statement. The relative max is y equals whatever the y value of the ordered pair is when x equals blank. So we take apart our ordered pair. The y value is first. That's always the max or the min, and they always occur when x is equal to whatever value we're getting. So likewise, for a min, we would say the relative min is y equals, again, whatever number when x is equal to whatever number there. All right, so we're going to take a look at an example where we kind of pick out all of these pieces. We're analyzing the graph. Now, on a lot of these problems, I'm going to give you this nice window, this viewing area, Now the picture I have here is from my calculator, but I'm also going to walk you through Desmos. So please copy down this equation here, y is equal to x to the fifth plus 2x to the fourth minus 12x cubed minus 13x plus 10, and then type that into Desmos or your graphing calculator. Desmos is going to be a lot easier though. All right, so this is what you should get the first, as soon as you type this in. I'm going to show you, I don't want you guys just zooming in and out. I'm going to show you how you can type in those values that I give you so everybody is looking at the same image, the same size. So if you go up here to the right top corner where you see this wrench, where it says graph settings, that's just the icon for tools here. And right here where we have this inequality for the x-axis, we're going to switch out that -10 and make it a -6. Then on the other side, delete that 10 and make it a 6. Because that's what I gave you for the problem. X should go from -6 to 6. For the y value, the lowest value here, switch that out. Let's make that a -150. Let's do the y max at 400. And everyone should have this image. So this is what I was looking at when I typed that in. So when I give you this, this is your x min, this is your x max. Again, this is just interval notation that I'm giving you. This is your y min, so all the y's are going from -150 to 400. All right, so let's go ahead and just click on the x-intercepts. We've got one point here. We've got another point here. This is what's nice about Desmos, is it kind of already brings these points up. And then we can click right there. So when we go to answer what are the zeros, we're just, notice how all the y's are 0. We don't need to state that. We're just going to list all of the first numbers here. So when we go to do that, we're going to say the zeros are, and as we go from left to right, a -4.699, a 0.598, and then a 2.771. Those are the zeros or the x-intercepts. Now let's take a look at the extrema. What's nice about this too is it already has the points ready for us, but we're not listing them as ordered pairs. Remember, we say the y, or the relative max, is the y value when x is given here. So let's go ahead and write those out. So we're going to say the relative max is y equals at 348.162 when x is equal to -3.635. And then we say the relative min. If we go back to that picture here, the relative min is its -48.695 when x is 2.103. Like I said, I graphed this on my calculator. There's a lot more we have to do to trace the features, analyze the graph on a calculator. Desmos makes this so much easier to figure out these values. But it's important just to know what the terminology is, what a zero is, how we find and state a relative max and min, and then where they occur. All right, so off of today's handout, I want you guys just doing 1 through 4 only. Like I said, and we're going to review a little bit each day. Individual quiz Friday over solving quadratic equations. That's what the first 2 warm-up problems were. And then what your graded assignment was yesterday, writing a quadratic function in vertex form and then graphing that. So please let me know if you guys have any questions.